Okay, so good evening, everyone. So we are here today to learn and summarize and reteach the main concepts in atomic structure and in chemical bonding. All right, so let's start off with atomic structure. So basically, it starts off with the idea of an atom. An atom is the most basic building block of matter. That means no matter what chemical substances you are looking at, it must be made out of atoms or it must have been derived, come from atoms. So if I wanted information about an atom, I will go to the periodic table. So the periodic table of elements gives me information about an atom of the element. All right. So now, in an atom, what are there? So the first thing you need to learn are what we call subatomic particles. So as the word suggests, subatomic means what is inside an atom, what makes up an atom. So your atoms are made up of three types of subatomic particles. Of course, you have learned this before. The three types of subatomic particles differ in terms of their relative charge and their relative mass. Okay, and the three subatomic particles that we are talking about are protons, electron, and neutron. Okay, so I'm sure you remember these three. Okay, but let's also remember that these are the three types of subatomic particles. So as the name suggests, protons are positive, and therefore their charge is +1. On the other hand, electron, when you pronounce the word E, your mouth is like a minus sign. So electrons are -1 in charge. Finally, neutrons, they are described as neutrons because they are neutral in charge. So 0. Okay, so these are the relative charges of the protons, electrons, and neutrons. Okay, so now we move on to the mass. In terms of mass, protons have a relative mass of 1. Electrons are very light. How light are electrons? Now, electrons are light. They are 1,840 times lighter than a proton. Okay, so 1840. So 1 over 1840 is the relative mass of an electron. Finally, neutrons have the same relative mass as a proton. Okay, so I believe this table, you are familiar with it. So it's important to commit this to memory because if you look at the 10-year series combined science questions, they have actually asked you before to fill in and complete this table. So it's something that you can definitely study for, prepare for. Now, when you also study this, don't forget to study the last column, which I have not added in. The last column is called location. So where are these subatomic particles located in an atom? So the protons are located in the nucleus. Okay. On the other hand, the electrons are not inside the nucleus. They are not in the center of the atom. Okay. They are actually in the electron shells around the nucleus. So the electrons are found in shells, which are around the nucleus. They are outside the nucleus. And of course, neutrons, they are found in the nucleus as well, just like protons are. So don't forget the last column, the location in an atom where you can find these subatomic particles. Okay? Now, once you have memorized this table, it is time to apply your understanding to solve questions. What do I mean? Now, the first thing you notice is there are two different particles in the nucleus, right? The protons and the neutrons. They are both found in the nucleus. And that's why protons and electrons collectively, they are called nucleons. nucleons. Now, this word is a word that sometimes students get confused about. Nucleons just means what particles do you have inside the nucleus. So inside the nucleus, we have protons and neutrons. That's why they are called nucleons. Okay, you see this word very often in TYS as well. They ask you, tell me what is the number of nucleons in this atom. So when we say nucleon, we mean proton and neutron added together. Okay, so that's the first application you need to know. Now, the second application you need to know also has to do with the nucleus. You notice that in the nucleus, you have the protons and neutrons. Protons and neutrons both have a mass that is 1. So as compared to an electron, a proton and neutron is much heavier. And this leads to the next conclusion. The nucleus is dense. Or another way of saying it, most of the mass of an atom is in the nucleus. Okay, the mass of an atom is mostly concentrated in the nucleus, and that is logical because the nucleus contains protons and neutrons, which have a relative mass of 1. This is much heavier than an electron. Okay? Can? So a simple table with relative charge, relative mass, and the locations can actually lead to a relatively large number of applications that you need to know about. Okay, so please ensure you have taken this section on subatomic particles down before we move on to the next section of the summary, where we will look at how you can get information about atoms from the periodic table itself. Okay, so let's continue with the next section, where we will make use of a periodic table to find the number of subatomic particles. Okay, so remember, to find the number of subatomic particles, we need to use the periodic table. So for those who are tuning in for this lesson, please ensure that you have a periodic table with you. Okay, so the first step now, we can easily work out. Let's say I give you an element called potassium. So potassium's chemical symbol is K. So you look for potassium. Then you will find these two numbers, right? 19 and 39. So what do each number actually mean? So the smaller number, 19, is known as the proton number. Now, the proton number is also known as the atomic number. Okay? It is known as the atomic number because every single element has a different atomic number. That means in the whole periodic table, there is no other element with atomic number 19. So what is this actually defined as? 19 is the number of protons in the nucleus of one atom of the element. That means in one atom of potassium, there will be 19 protons. So this automatically means potassium has 19 protons. All right. Now, if potassium has 19 protons, the potassium atom must also have 19 electrons. How do I deduce that the electron must also be 19? I deduce this based on the fact that atoms have no overall charge. So atoms on their own should not be plus or minus. The atom of potassium is just K. It's not K plus. All right. So how is it possible that it has no charge? Well, that is possible if the positive protons are balanced out by an equal number of negative electrons. Therefore, the protons and electrons for an atom must be the same. Okay? And finally, we can easily work out the neutrons must be 20. We got 20 by taking 39 minus 19. Okay, so what is 39 actually? 39 is the mass number. The mass number is also known as the nucleon number. So this word nucleon should ring a bell. We did this in the previous section. So what is nucleon? Nucleon is the total number of protons and neutrons in the nucleus of one atom of the element. Okay, you will need to know these definitions. You will need to be able to define atomic number, define nucleon number as well. Okay, so nucleon number is the total number of protons and neutrons. Therefore, to find the neutrons only, we will take the nucleon number minus the proton number. So 39 minus 19 gives you 20. Okay, so that's how we can make use of the periodic table to find the number of subatomic particles. Okay, now this is really, really useful because once we have the number of subatomic particles, we know exactly how many protons, electrons, and neutrons an atom would have. And for chemistry, to predict chemical reactions, reactivity, the key character is always the electrons. Okay, so for the Sec 4 students here, actually, all the chemical reactions you have learned so far, all of them, okay, the vast majority of them will involve some electron movement. Either the electrons are lost or gained, all right? So electrons are actually the main character in chemistry. And that's why we come to the next important section, which is what we call electronic configuration or structure. Once you know, okay, the electrons, how are they arranged, you can predict so many things out of it. All right. So now knowing the number of electrons is the first step from the periodic table. The second step is actually knowing how are they arranged. So in the case of potassium, you already know that potassium has 19 electrons. How will you then arrange the 19? The first shell, 2. Second shell contains a maximum of 8. The third shell usually contains a maximum of 8 as well. So first shell 2, second shell 8, third shell also usually 8. So that's 2, 8, 8. If you add up 2, 8, and 8, that's already 18 electrons. Therefore, to make the 19th electron, the very last electron goes into the fourth shell. So this is crucial in many, many ways. Just by working out that it's 2881 in terms of electronic structure, we can work out so many things. Take, for example, potassium must be in group 1. Why? Because potassium has 1 valence electron. So elements in the same group have the same number of valence electrons. The meaning of the word valence is the outermost shell. How many electrons do you have in the outermost shell? Okay, so just based on the outermost shell having 1 electron, I can say that potassium has 1 valence electron. And therefore, potassium is found in group 1. Now, besides group, which is top to bottom, group 1, group 2, and so on, we also have period. In a periodic table, the period goes from left to right. Potassium is in period number 4. How do we work out that it's period number 4? So group was the valence electrons. So what's for period? To work out the period number, we look at the number of electron shells that contain electrons. you can say this. Potassium has 4 occupied electron shells. So I'm actually looking at the number of electron shells, which you can tell first shell, second shell, third shell, fourth shell. Because it has 4 occupied electron shells, therefore, potassium is found in period 4. Okay? So if you have done your TYS, you have realized that, hey, there are some questions that look exactly like this. For instance, they can ask you to name an element and state how the electronic structure allows you to work out the position of the element in the periodic table. Position of element in the periodic table means group and period. So how do you work out the position of potassium in the periodic table? This is how you work it out. Potassium is in group 1 because it has 1 valence electron. Potassium is in period number 4 because it has 4 occupied electron shells. All right. So this simple analysis of electronic configuration is already indeed very, very useful. Okay. So let me just give you a little bit of time to internalize and copy that down. Okay. So besides finding out the position of the element from the periodic table, the electronic structure also gives us many insights as to what actually happens during a reaction. So take, for example, potassium. Potassium atoms have electronic configuration 2881. The 1 electron, though, in the outer shell makes it extremely reactive. It makes the potassium extremely unstable and explosive. The reason is because the 1 electron in the outer shell means that the outer shell is not fully filled. So the concept here is all elements will lose or gain valence electrons to achieve a fully filled outermost electron shell. So if you have 2881, that 1 valence electron has to be lost. So potassium will lose the 1 valence electron. And when you lose the 1 valence electron, I'm sure you can work out, it literally becomes 288. And now, what has happened is that it has lost 1 valence electron. So it's no longer going to be the same as before. It's not the same as before in what sense? If now we were to count the number of protons, electrons, and neutrons, originally, I had 19 protons. Originally, I also had 19 electrons. But now that you tell me that I have lost 1 valence electron, this automatically means I now have 1 less electron, 18. And this makes sense because 288, 2 plus 8 plus 8 is 18 electrons only. And finally, 20 neutrons. So you can see immediately, there is a different number of protons and electrons. Specifically, protons has more. There's 1 more proton than electron. And hence, this is now the K plus ion. So what is an ion? An ion is a charged particle. It can be positive or negative charge. It's a charged particle that is formed when atoms lose or gain valence electrons. All right, so in this case, the K plus ion is formed when potassium atom loses the 1 valence electron. Okay, and the reason why it's plus is because you have lost 1 electron, which means the overall effect is there's 1 less electron than protons. That means there's now more positive charge, less negative charge. Hence, overall, it's positive. All right. Now, this one should be straightforward. I'm sure you know by now it forms K+. However, for O-level combined science, very often you are asked to describe this process. So how would you describe this process in words to explain how potassium forms the ion? So this is how you can describe. The potassium atom 2881 loses one valence electron. All right, so this is exactly what we said. It loses one valence electron. What's the purpose? It forms the K+ ion with a fully filled outermost electron shell. So many students often forget the purpose. The purpose of losing the one valence electron is to form an ion with a fully filled outermost electron shell. So this is very important. This sentence, if you can write it in this format, addresses both how it forms the ion, why it forms the ion. All right. So this is an example using potassium. All right. So now let's move to a different element. And this different element that we're going to be looking at will come from the other side of the periodic table. So now let's look at the other side of the periodic table from potassium. So we can select the atom oxygen, O. All right. So let me just partition these two parts so you can see more clearly. So the oxygen atom, if you look carefully in the periodic table, you will see that oxygen atoms have 8 protons, and therefore they also have 8 electrons. So oxygen atom is 2,6. So I'm sure you can predict 2,6 won't be very stable. 2,6 means this element must be in group 16. When you go to the other side of the periodic table, the group numbers all start in the teens, 13, 14, 15, right? So now oxygen is in group 16. How can you tell that? If it's in the teens, 13, 14, 15, 16, the last digit is the number of valence electron. Oxygen has therefore 6 valence electrons. And hence, oxygen is in group 16. Oxygen is in period number. So let's think again. We said just now, group is the number of valence electrons. Period, on the other hand, is the number of shells which are occupied. And therefore, oxygen is in period 2. So oxygen has 2 occupied electron shells, therefore oxygen is in period 2. Okay, so I'm sure you can quickly work this out by now. Okay, as practice, always go to the periodic table, select an element from the 1st to the 20th element and see whether you can reason this out yourself. Okay, so obviously, now that you know oxygen has 6 valence electrons, it's in group 16. Now, if it's in group 16, clearly this is not stable. It doesn't have a fully filled outermost electron shell. And therefore, for oxygen to gain stability, it needs to make the outer shell fully filled. And the only way it can do that is to gain 2 valence electrons. And hence you end up with 2, 8. But once you do that, you realize that, hey, I gained 2 electrons. Electrons are negatively charged. I gained 2 of them. Therefore, this ion now has a 2 minus charge because you gained 2. So 2 minus, because each electron is negative. 2 electrons, 2 minus. So this is called the oxide ion, which I'm sure you are familiar with by now. Okay, so we say that the oxygen atom 2,6 gains 2 valence electrons And this purpose of gaining is to form the O2 minus ion with a fully filled outermost electron shell. Right? So up to this stage, you have already addressed how the ions are formed, okay, and why do they form the ions, okay? Now, just based on this, it links to many, many things later in ionic bonding, as well as in chemical formula writing, okay? So if you are weaker in chemical formula writing, you need to return to basically how ions are formed so that you can practice how to write chemical formula correctly. Okay, so let me just pause here for a while to ensure that everyone is keeping up, and then before we move on to formula writing. Okay, so at this juncture, I'm sure you are aware of how ions are formed and also the reason why ions are formed from the atoms. Okay, so this is crucial. Now, besides that, something else that you need to take note of is how do you distinguish positive cations from negative anions? All right, so this is an important tip. So you notice K plus is a cation. It's a cation because they have more protons than electrons. All right. So cations can be identified because they have more protons. This means that cations must have been formed when something lost electrons. That's why there are less electrons now. On the other hand, anions, which are negative ions, have more electrons. And they have more electrons because they have gained electrons. Okay, so this is how we can distinguish between cations and anions on the basis of their numbers of protons and electrons. Okay, so just to recap, atoms, proton and electron same. Cation, proton more, plus. Anion, electron more. So it's minus charge. Okay. Now, next thing we can also generalize using potassium and oxygen. Potassium is a classic metal. It's an example of a metal. So we can generalize and say metals lose valence electrons to form cations. Whereas the opposite, non-metals gain valence electrons to form anions. Now, this is really crucial later on when we do the periodic table. All right. Many students are often confused. How do you explain the metallic character of the element? The metallic character is not whether it looks shiny. The metallic character, as defined in chemistry, is about whether it loses electrons. A metal should lose valence electrons in order to form cations. On the other hand, non-metals gain valence electrons. Okay? And this leads us nicely into the concept of an ionic compound with ionic bonding. So now that we have talked about ions, we are ready to talk about ionic bonding. So if I told you that potassium and oxygen came together, if potassium and oxygen reacted together, they form potassium oxide. So whenever we say potassium oxide, please do not assume that it's KO. That's incorrect. What's crucial here is that you need to know, okay, this is definitely a compound. And this is an ionic compound. I know it's ionic because there is a metal and there is a non-metal. If you look at the purple box on top, we just said metals lose valence electrons to form cations. Non-metals gain valence electrons to form anions. Therefore, when you see metal and non-metal in the same compound, it's ionic. And if it's ionic, you need to think about charge. So now we can look at this. Potassium, we just did the analysis just now. 2881. 2881 loses one valence electron. So it's K with a positive charge on the ion. On the other hand, oxide O26. 26 will gain two valence electrons to achieve a fully filled outermost electron shell. So it's 2 minus because it gained 2 electrons. And therefore, the formula is not KO. Potassium lost 1 electron. Oxide was formed after oxygen gained 2. Potassium lost 1, oxygen gained 2. This means that you need 2 potassiums for 1 oxygen. Another way to see it is the charges have to balance each other out because the final compound should not have any more plus and minus, meaning the plus must be balanced out by the minus. So in this case, you can clearly see oxide is a 2 minus ion. Therefore, you will need 2 times the amount of K plus to balance out 1 oxide ion. So we say K2O. The number is written at the bottom. This is called formula writing. When you're writing the formula, you are balancing out the positive and negative charge. When you're balancing out charge, you write the numbers at the bottom. Okay? Now, this also allows you to work out that, okay, because it's K2O, when drawing the dot and cross diagram, I must draw and reflect that there are 2 K plus. How do you reflect that there are 2 K plus ions? First, K. K is 2881, but it's K plus now. K plus means 2881 became 288 because it lost the 1. 2, 8. Notice that we always pair up the electrons. And I draw north, south, east, west. So 2, 8. 8. That is my K plus. I need to show the plus. I will have to square bracket the whole thing, put the plus charge on the top right corner. Then how would I reflect that there are 2 K plus? I will reflect the 2 K plus by writing the 2 outside the structure of the K plus ion. So you notice, in the formula, the 2 is at the bottom. But when drawing dot and cross, the 2 appears outside of the square brackets of the ion structure. Okay, so this is a convention you got to learn. In a formula, the 2 is at the bottom, but now when drawing a dot and cross, the 2 is actually referring to 2 times the amount of the ion K plus. So it's written outside. Now we have O. O is 26. However, it gained 2 valence electrons. So now it's 2, 8. 2 in the first shell. Now, the 2 electrons were gained, but the 2 electrons gained came from potassium. And therefore, we need to reflect. We should reflect that the electrons came from another source. We should reflect the 2 electrons were gained from potassium by using a different symbol. Finally, square bracket up, the charge is 2 minus, put outside. So this is the dot and cross diagram for potassium oxide. All right. Now, definitely, you may be asked to draw the dot and cross diagrams. So you need to be familiar with the dot and cross diagram. And for O-level combined science, very often, we do not give you the formula of the compound. So we will just give you the name potassium oxide, and you will need to work out that, okay, Potassium oxide is made up of K plus O2 minus. Therefore, the formula is K2O. Hence, the dot and cross diagram must have 2K plus, then 1 O2 minus. Okay? So now we can practice a little bit. We can try out aluminum oxide. So I hope you have a periodic table in front of you for those on the Zoom meeting. And for those who are watching the video, please go get a periodic table now. Work out the formula of aluminum oxide. And after working out the formula of aluminum oxide, let's draw the dot and cross diagram for aluminum oxide. All right, so I shall pause the recording here for a while for the rest to work on it. Okay, so for those watching the video later on, I hope you have already worked on the dot and cross diagram for aluminum oxide. Now, it's very important to invest time to doing this properly. So the first step is figuring out what is the chemical symbols, of course, Al and O. Now, Al is from group 13. This is group 13. And Al has 13 electrons. So the Al atom is 283. All group 13 elements have 3 valence electrons. Remember, for the teens, it's the last digit that gives you the number of electrons in the outer shell. So group 13 has 3 valence electrons. If it has 3 valence electrons, means it's going to lose 3 valence electrons. And therefore, the charge is 3 plus. So all the group 13 elements form 3 plus charge in their ions. Okay? Now, oxide, we have gone through this. Oxygen is 2,6, right? But because it's 2,6, it will gain 2 valence electrons to form 2,8. So in short, oxide is O2 minus 2,8. Al3 plus is 2,8 as well, because 2,8,3, you lose 3, became 2,8. Now, this is very important to count properly. Sometimes you may miscount and then you draw more shells or more electrons than what is needed. So this is what you draw. You need to draw 2,8, 2,8. Okay? Now, besides that, you realize that the charge is 3 plus and 2 minus. So how then do you balance out the charges to write the correct formula? So the idea here is to work out the lowest common multiple between 3 and 2. The lowest common multiple, of course, is 6, meaning the 3 plus needs to go to 6 plus. How? How do you go to 6 from 3? Well, if you have 2 aluminium, then it will have 2 times 3 plus, which is 6 plus. If you have 3 oxide, then it will have 3 times 2 minus, which gives you 6 minus. So always look for the lowest common multiple. In this case, 3 and 2, the lowest common multiple is 6. So think, how are you going to make each number 6? The one on the left, aluminium, put it as a 2 aluminium, so Al2. The one on the right, 3 oxygen, so O3. So Al2, O3. So now you are ready to draw. It's just 2,8 for both. Okay, so it's not difficult. Just ensure you draw carefully, ensure you count properly, indicate the charges carefully. There's 2 aluminium, so it's 2 Al3 plus. The O2 minus. And you have 3 O2 minus, and that's it. Al2O3 is the chemical formula of aluminum oxide, and that is the dot and cross diagram, which shows you the bonding in aluminum oxide. Okay? Now, unless the question specifies, you should always draw all the electrons present in the ion. Meaning, please don't just draw the outermost shell, ensure you also draw the inner shell. Because if the question doesn't specify, you should draw all. All right? Now, so since we are on this topic, let's look at what keeps these ions together. Why is it that the Al3 plus is attracted and stays together with the O2 minus? It's attracted and they stay together because there are strong electrostatic forces of attraction. Okay, so there are strong electrostatic forces of attraction between the two ions. So recall, these are ions because they have charge. So these forces of attraction are known as electrostatic forces of attraction. Now, why do we call them electrostatic? And what is the meaning of electrostatic? Now, electrostatic simply means positive attracts negative. So basically, it's an attractive force between opposite charges, plus and minus, which is logical because we have learned that opposite charges attract. So such a force of attraction is called electrostatic force of attraction. Okay? Can? Now you need to be able to state this whole phrase as strong electrostatic force of attraction between ions. Now, this obviously has implications on the properties of ionic compounds, which I think is something that you would have seen a lot in, be it last year in your WAs, end of year exam, as well as the TYS, and later on you will see all the past year prelim papers that you will do. We often ask you, oh, so explain why aluminium oxide has a high melting point. So obviously, it has something to do with the forces of attraction. So now let's move on to the physical properties of ionic compounds. All right. So what are the physical properties of ionic compounds? Now, the first physical property is what I just said. Ionic compounds like aluminum oxide, potassium oxide, sodium chloride, so long as it's ionic, it has metal and non-metal, it's ionic, it will have a very high melting point and boiling point. MPBP stands for melting point and boiling point. The temperature needed to melt and boil ionic compounds is very high. Now, in order to melt a substance, you have to allow the particles to actually move further apart. And for them to move further apart, you have to overcome the forces of attraction between them. So now let's think, what are the forces of attraction present in an ionic compound called? So the idea is, the forces of attraction that are present are strong electrostatic forces of attraction between the ions. Right? So state the name of the forces of attraction. So let's say aluminum oxide. There are strong electrostatic forces of attraction between the Al3 plus and O2 minus ions. Because these are strong forces, strong electrostatic forces of attraction, they are strong, right? So if they are strong, they require a lot of heat energy to overcome. I need to overcome these forces of attraction before the particles can move further away from each other. And they are strong, so it requires a lot of energy to be supplied. And therefore, the melting point must be very high. So all the ionic compounds that you have learned, those compounds that have a metal and non-metal are ionic. Ionic compounds always have a high melting point. Now, how high is high? There's no fixed definition. Generally, more than 500 degrees Celsius. So generally speaking, ionic compounds have a melting point that is more than 500 degrees Celsius. Okay, so that's the first physical property, a high melting point for ionic compounds. Okay, now the second physical property also has to do something with the forces of attraction and the particles. It's about conducting electricity. So we are always interested to know, what can these materials be used for? So like aluminum oxide is a material that we can use, but what can we use it for? Is it a good conductor of electricity? And the answer is no. Aluminum oxide does not conduct electricity in the solid state. So as a solid, ionic compounds will not conduct electricity. If I put a battery and a light bulb to the ionic compound as a solid, the light bulb won't light up because it doesn't conduct electricity in the solid state. But will conduct electricity in the molten and aqueous states. So as a solid, doesn't conduct, but when melted or when dissolved in water, it will conduct. Okay, so what is molten? Molten means liquid state. Aqueous means dissolved in water. AQ is a state symbol. Okay? So this is very unique, very, very unique to ionic compounds. Only ionic compounds behave like that. They do not conduct in the solid state, but will conduct electricity in the molten and aqueous states, which you need to know how to explain. Okay? So for the physics students in this group, okay, I'm sure you can appreciate what is electricity. Electricity or electrical current is the flow, the rate of flow of charge. So the keyword here is flow. That means your particles must be able to move freely. So now you got to think, are my particles going to move freely as and where they like in the solid state? So you got to think back. When you learn solids in Sec 1, for example, what did we learn about solids and particles? In the solid state, the particles, and these particles are called ions because it's ionic compound. So the ions are held in fixed positions. So in the solid state, your ions are in fixed positions. They are vibrating about fixed positions. And what keeps them there? The forces of attraction called strong electrostatic forces of attraction. Okay, so the ions are held in fixed positions by strong electrostatic forces of attraction. And so the ions are not free to move, to conduct electricity. Okay, fixed position means not free to move. So solid state, done. Explained why it doesn't conduct, because the ions are not free to move. So now let's move on to explain why it conducts suddenly in the molten and aqueous states. In the molten and aqueous states, the ions are free to move, to conduct electricity. So now, once you dissolve it in water, once you melt it, the ions can move freely. So if I connect battery and light bulb to the aqueous solution, it lights up the light bulb because it's now an electrical conductor. The ions are free to move. And this is because by melting or dissolving in water, the strong electrostatic forces of attraction have been overcome. When we melt something, like just now we talk about melting point, we talk about overcoming the forces of attraction. That's the same here. If it's molten or aqueous, the strong electrostatic forces of attraction have been overcome. As a result, the ions are now free to move to conduct electricity. Okay? Can? So, if you look at the flow of the summary today, we have gone from something really, really basic, which is what is present inside an atom. Proton, electron, neutron, right? Then we spoke a little bit about what an atom looks like. We have moved on from there to look at the periodic table. How you can use periodic table to actually work out the numbers of protons, electrons, and neutrons. Then in section number 3, point number 3, right? We actually talked about electrons being the main character of chemistry. So throughout chemistry and chemical reactions, electrons are what you focus on. How many electrons you have? And how are the electrons arranged into shells? So in point number 3, we spoke about electronic configuration, how electrons are arranged into shells. And under that, once we know electronic configuration, we can work out the position of the element in the periodic table, its group, its period. And also, what kind of ions will it form? Will it form positive or will it form negative ions? And once we understand the concept of losing electrons, gaining electrons, forming ions, once you know the concept of ions, how to work out the charge of the ion, then you can work out how to write chemical formula. All right? Once you can work out how to write chemical formula, then you can work out how to draw dot and cross diagrams of ionic compounds. And finally, we appreciate that ionic compounds are made up of metal and non-metal. So such compounds are ionic compounds, and ionic compounds have these unique physical properties like high melting point, no electrical conductivity in the solid state, but high electrical conductivity in the molten and aqueous states. And this is how you explain these properties. Okay? Now, before we go off, you need to know how to predict the charges on ions. Okay, I'm sure you know by now, ions are formed when atoms lose or gain electrons. So this is determined by the number of valence electron, right? So all the elements in group 1 have one valence electron. Therefore, all the elements in group 1 will lose one valence electron. If you lose one valence electron, the charge is 1 plus. So like Li plus, Na plus, K plus, so on and so forth. Group 2. Group 2 has 2 valence electrons, and therefore you will lose 2 valence electrons. When you lose 2 valence electrons, it forms 2 plus charge. All right? So if it forms 2 plus charge, example, beryllium 2 plus, magnesium 2 plus, calcium 2 plus. So these are the common ions of the group 2 elements. Then we move to the other side, group 13, the teens. Anything that is teens, you just look at the last digit. 13, the last digit is 3. So it has 3 valence electrons. Therefore, it loses 3 valence electrons to form 3 plus charge. The best example, aluminium, we just saw, Al, 3 plus. Then we have group 14. Group 14, 4 valence electrons. Usually covalent bonding, meaning it doesn't form ions. So like carbon forms covalent bonds by sharing electrons. And that's what we will cover next time round. All right. But carbon usually shares electrons. It doesn't form ions. Then we move to group 15. Again, the teens, 15, the last digit is 5. So that means group 15 elements have 5 valence electrons. If they have 5 valence electrons, to achieve a fully filled outermost shell, they must gain 3 electrons. If you gain 3 electrons, the charge is 3 minus. So you have N3 minus, P3 minus. Not common, but it exists. Group 16, 6 valence electrons, so it gains 2. O2 minus. All right? Okay. So the charge is 2 minus, so it forms O2 minus. Then we have the halogens, group 17. Again, it's a teen, so it's 7 valence electrons. If it has 7 valence electrons, it gains 1 more to achieve a fully filled outermost shell. So F minus, Cl minus, Br minus, I minus. At, the last one, also minus. All right. So from the group number, we can usually predict what charges it will form. And that is the first step in writing the correct chemical formula, predicting the correct charge. However, there are some ions that you have to memorize. Zinc is Zn2 plus. Silver, Ag plus. Ammonium, NH4 plus. So these are the three cations that must be memorized. And then you have several anions that have to be memorized. Hydroxide, OH minus. Nitrate, NO3, the 3 is at the bottom. The 3 refers to 3 oxygen. The charge is actually just minus. So take note, the charge is 1 minus. So nitrate is 1 minus charge. Then we have the carbonate. It's CO3, 2 minus. Again, the 3 is at the bottom. 3 oxygens. The charge is 2 minus. And finally, we have sulfate. SO4, 2 minus. Again, the charge is 2 minus. So these are the ions that have to be memorized. Okay? So some, or not just some, the vast majority, you can predict using the periodic table. However, there are some ions that have to be committed to memory. Okay? And so with that, once you have memorized these ions and are able to work out from the periodic table, you will be able to write chemical formula very, very well. Okay? So chemical formula is a journey. You will need to practice writing it. All right? So every single time you receive an equation, try writing the chemical formula. Let's say magnesium nitrate. What's the formula of magnesium nitrate? And so on and so forth. So for the Sec 3s who are in this Zoom chat, yeah, that's the reason why we have frequent formula quizzes. It's because formula quiz forces you to practice. You need to be forced to practice writing the chemical formula. You may not get it immediately, but you will get it once you practice enough. Serious. Okay? Now, hopefully today has given you an introduction as to what atoms and also ions and ionic compounds are. Okay, so that's the main objective of today. Now, tomorrow we shall meet again, and tomorrow's main objective actually is to revise acids and bases. All right, so after we finish revising acids and bases, then we will go back to covalent bonding if we have time. All right, so tomorrow I'll see you at the same time at 8 o'clock to revise acids and bases on the same Zoom link. All right, let me stop the recording here. Thank you.